Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss another one topic on viscous resistance of collar bearing. So in a previous lecture, already we've discussed two different types of bearings, like the viscous resistance of journal bearing and the viscous resistance of footstep bearing. Now we'll discuss another one part of this bearing viscous resistance, that is collar bearing. So in the collar bearing, if you see the diagram, it is slightly different from the others, but it is similar to the footstep bearing. If you rotate this one in axially, this bearing part, so this shaft and this bearing, if you rotate in the axially, then you can get a similar kind of concept of footstep bearing also. So here, this is the shaft part is there, and the shaft is attached with this collar. So this is the collar part, and the collar and bearing both are separated by a fluid, and this fluid is nothing but oil film. So this is the bearing part is there, and which is fixed, and this is the oil film, and the thickness between this bearing and this collar surface. Okay, see, this collar is not connected with the bearing part, you can see here, and that is just separated by this oil film. And also you can see the shaft will be started rotating, means the shaft also connected with the bearing, but with a gap of this oil film. So the gap or this thickness of this oil film is nothing but T. So if you have seen the previous videos, there already have told what are the parameters are required to derive this equation, or to derive this to understand this concept. So few terms are there which need to be identified or need to be discussed here. So as I told, this is similar kind of like a footstep bearing. So this is the shaft part is there. So shaft is, if you see, so this is the here shaft diameter, and this is the collar part is there. This is collar, and its collar is having two diameters. Okay, one is external diameter, external this one, and one is internal diameter. Internal diameter is up to this here. Okay, so and here another, again we need to consider another one elemental part of this ring. So which is previously, as we have taken, this is the elemental part we need to consider, so that we can find out the power absorbed in that. Okay, so this is the elemental ring which is situated with a distance of r and with a thickness, or we can say this one, width of dr. And what are the parameters we need to consider here? So to calculate, we need to consider first one, n. N is what? N is the speed of the shaft, which is supposed to be rotated with an RPM. So n. Next is R1. R1 we can see here, this one. This is the internal radius of the collar. This collar is there. This is the internal radius, means from here to here. Or you can see the radius from the center line, or is from the center point to up to here. Okay, this is the internal radius. Similarly, R2 is there, that is external radius of the collar. And next is T. T is the thickness of the oil film. Thickness of the oil film between the shaft, you can say, of bearing, or between the collar and the bearing also. Now, to find out this power absorbed, again we need to consider, okay, an elemental circular radius. As I told, this is the elemental part what we are considering here. So consider an elemental circular part of which is a radius of r, small r, and as I told, the thickness or the width of dr of this bearing surface. Then we need to find out what? We need to find out finally the torque of this shaft rotation, we can say, or which is equal to overcome the viscous resistance, okay, on the elemental ring. Okay, so this, as I told, this is similar to the footstep bearing. So if you have seen the footstep bearing equation or the video, we can get it directly, the formula what we got there, dt equal to, we got mu by 15t, and which is value was there, pi square n and something r will be there, rq dr. So this was the equation we got during our footstep bearing, and this is the dt. Okay, I'll tell you if you have seen that one, well and good. Otherwise, I'll derive from the starting. Like we need to start from the area part actually. So we need to start the area of the elemental ring. So we need to calculate. So here not A, we need to consider dA because it is a very small one. So dA we can write 2 pi r dr. This one we can give a equation 1. So as I have calculated the dA, then I need to go for the finally I need to calculate the this torque. So to calculate the torque, as I told previously in the previous video, that we need to calculate the shear force. So shear force calculation means we need to calculate the shear stress. So now I need to go for the shear stress. So shear stress, as per the Newton's law of viscosity, we know that tau equal to mu into du by dy. I can write du by dy. So du is nothing but the velocity at what it is rotating, the shaft is rotating. So this velocity is nothing but tangential velocity you need to consider, and this dy is nothing but the thickness of this oil film. So this one I can write in terms of also equal to mu into v by t. So this v is nothing but tangential velocity. So again in this v I can write tangential velocity equal to omega into r. In the place of omega I can write 2 pi n by 60 into r. Okay, this is the value of v. So again just put the value of this v in this equation, so that I can write tau equal to mu into 2 pi n r by 60 into t. So this is the equation of tau. So this one we can give equation 2. Now this is about the shear stress. Now we need to find out the shear force. So we know that shear stress equal to shear force by area. So shear force, again I can write dF equal to shear stress into dA. So just if you put the value of tau, this value, and dA value, this one already I have derived in the previous video if you have seen. Again I'm repeating that one. So we can write this dF equal to finally we can write mu by 15. Mu by 15 will come because 2 and this 2, 4, it will be cancelled 60. So 15 will be there. So mu by 15t, again we'll get 2 pi, so pi square. Next we'll get n, only single n, and 2r are there, r square will come, then dr. So this is the df equation. So this one we can give equation 3. Now we need to go for the torque. The torque equal to overcome the viscous resistance. For that one I can write dt, the small dt I can write, that is nothing but df into the force into radius. This is the formula for this. So df already we calculated here. Again just to multiply r into that. So that is nothing but mu by 15t. So this is pi square, and this is n, and this is r cube, and this is r dr. Sorry. So if you see the equation what I have written here, dt equal to mu by 15t pi square n r cube dr. So same equation I got here. So now, so up to this it is similar to both full step bearing and collar bearing. Now we need to find out the power resistance for this. So what we'll do, the torque required to overcome the viscous resistance, as I told this one. So we need to integrate this. And previously we have done integration from 0 to r. From 0 to r. Now we need to integrate this one from r1 to r2. From this internal radius to external radius. That is the only difference. So what I'll do, just I'll write t equal to integration r1 r2. This is dt. Okay. So this one we can write r1 to r2, just put all this value here. This is 15t pi square n r cube dr. So what are the constant terms? We can take it to outside. So remaining term will keep it inside, like mu by 15t and pi square n. Yeah, remaining terms will be there as usual. R1 to R2. This is nothing but r cube dr. See, the same concept we are just doing, just we are taking a constant outside and the remaining terms are inside, and only 0 to R1 we have taken initially. Now we need to consider R1 to R2. So now we can solve this and we can get it what 15 by again sorry mu by 15t pi square n. So this one we can get it like r to the power 4 by 4. So again we can take it this 4 outside, so multiply it, and in bracket what will there, now r to the power 4 upper limit minus lower limit. So this one we are going to get in this. Okay, so this one you can give a equation 5. Now what is our target? Our target is to find out the power absorbed. Okay, so this is our target. So power absorbed in overcoming of viscous resistance, in overcoming of sometimes it is destructive. Okay, so now what I can write, viscous resistance. Okay, so what is the formula for this? Now we know that P equal to 2 pi nt by 60. So we got the value of already t, so just put the value of t here. That means nothing but 2 pi n. So for the t, mu by 15t or mu by 60t pi square n. Okay, so this is nothing but mu by 60t, and we can write this is pi square n bracket start, and we can write this is r to the power 4 minus r2 to the power 4, and this is r1 to the power 4, and this is bracket close. Now we can get 2n and one more pi is there, and 2 this will be cancelled, so 30 will get. So finally we can write P equal to mu by we can get, yeah, this is P, mu value what I have written, so 2 pi n t value what I have written here, yeah, 60 t. Next what I can write, yeah, 2 pi nt by 60. So one more 60 is there. Okay, so this is the t value, so one more 60 is there actually, this one. So what I can write, mu, this is 60 into 30 t, and mu again pi will get pi q, because pi square into pi, and this is n square, and bracket start r2 to the power 4 minus r1 to the power 4. So if you see again, this is the equation, this is this much watt. This is the power absorbed in overcoming the viscous resistance. P equal to mu pi q n square by 60 into 30t bracket start r2 to the power 4 minus r1 to the power 4. This much watt. So what I mean to say here, like this is the similar concept of this footstep bearing is also similar to the this collar bearing is similar to the footstep bearing also, because if you keep the, here I have taken it is in the horizontal mode. Now this one if you take in the vertical one, similar kind of concept will get. Only one extra collar is added here, and which is in between bearing and the that oil film is between the collar and the bearing, and the shaft is as usual it is going to be rotated. So what are the main points we discussed here? Like again started from the area, then after that Newton's law of viscosity applied, formula we have taken tau, then we have calculated the shear force, and after shear force we have calculated the torque required, then the torque required to overcome the viscous resistance, just you integrate that one. Okay, previously for the, if you have remember, for the footstep bearing, this was the diagram was there. Okay, so for this case we have only taken from here to, from 0 to r1, this r radius. So here the concept we need to consider the collar part is what, now internal radius how much, this one outer part of this shaft, and the outer part of the collar you can say. So both are same, we have taken that one, that is the only difference. And finally the power required or power absorbed in the viscous resistance. So I hope you understand this concept, and if you are having any kind of doubt, query regarding this, you can give a comment on the comment box. Thank you all.